Hi everyone. Today we're talking about chapter one. Just a note moving forward, the chapters necessarily won't mean a whole lot to you guys. We don't really use the textbook too much, um, but the chapters are a good way to sequence what we're doing from one day to the next. So this first chapter is just about the basics of statistics, what statistics is, and a little more information about where we're headed this year. So I'll probably talk about this on the first day of school, or maybe I did already, depending on when you're watching this video. But statistics as a course is useful for everyone, and I think that's kind of the beauty of the class. So regardless of what professional or life goals you have, there's quite a bit of relevance when it comes to statistics. So first off, most colleges, actually a majority of college majors now require some sort of stats component. It also helps increase your ability to communicate precisely and accurately. And perhaps the most important thing is, especially in the age of a lot of information available online, it helps us learn to be skeptical of facts that are stated. We're going to see throughout the year that if you have a certain agenda that you would like to push forward, you can manipulate data such that it supports what you're trying to communicate to people. So I thought maybe it would be useful to maybe distinguish what statistics are, what statistics is. So the discipline, the class that you're enrolled in, AP Statistics with a capital S, that's the discipline that we're referring to. Okay, so if you say I am taking statistics class, statistics, that is the discipline with a capital S. And we define that as a way of reasoning along with a collection of tools and methods designed to help us understand the world. Now, if we're talking about specific statistics like calculating the mean, median, range, mode, things that you might find in sports, batting averages, those are the things you can think of. That's what we call statistics with a lowercase s. So those statistics we say are particular calculations made from our data. Now, later on, we're going to talk about the difference between statistics, like the things that we're calculating, and what are called parameters. Statistics come from our sample, whereas parameters are the true measures of our entire population. But like I said, we'll talk about that later. And statistics, they put our data values into context. So a simple number in statistics doesn't mean a lot. Typically, there's going to be some context behind that number. So a little bit about what statistics is all about. Um, the discipline of statistics, in short, really what we're interested in is variation. So when I say variation, I mean how much does what we observe differ from what we expect to have happen? So with different opinions on all topics, it's important to see how people's answers vary. So when we collect data from a sample, we expect individuals to be slightly different. So for example, if we knew in the US the average height of a female is 65 inches, well, if we randomly selected 100 people from Fargo North, 100 females from Fargo North, would we expect that average to be exactly 65? The odds of that happening are quite low, but we would expect that it would be right around 65. So that variation, that's the difference between what we expect and what we actually see. So in statistics, really what we want to know is how much of a difference from what we expect to what we observe is considered acceptable, okay? So if that difference is too large, we're thinking, oh, maybe something's going on here. Whereas if it's pretty close to what we expected, nothing wrong there, okay? Another example, if we knew that the mean time for Americans exercising in the US each week is 150 minutes, well, if we surveyed everyone at Fargo North and we found that the average was 200 minutes, well, that 200 is very different than the actual mean of 150 minutes for Americans. So we could make the claim that on average, Fargo North students are more active than the average American. So statistics, really, it boils down to analyzing the variation in our data set. Now, when it comes to doing statistics and making statistics useful, we typically follow these three steps, and don't feel like you need to write down think, show, tell. This is something that we're going to work on throughout the entire year. But if you've heard of the scientific method, it's kind of that same idea, this kind of systematic thing that we do in order to produce meaningful results in the end, okay? So the first thing you want to do, of course, is think first, okay? So we want to know, what is it that we're trying to analyze, where are we headed, and why are we headed there? So why are we studying this set of data? Why would we ever be interested in it? You just want to know what your purpose is going into an analyzing of data. Then this is something we're really going to spend a lot of time on. After you think about where you're headed, then you want to show what's happening in the data, okay? So that might involve calculating some statistics, so find the mean, the median, the standard deviation. It also might include making a graph, which is really important. If you think about it, looking at a list of numbers, not very useful. But if you put that into a graphical representation, you're able to analyze what's happening in that data set. So first you want to think about where you're going and why. Then you want to show what's happening in that data, either through calculations or through making a graph. And then finally, maybe this is what's going to differentiate this course from what you've done in statistics in the past, is that we want to tell about what we've learned. So based on what we see in our graphs, based on what we see in our calculations, what have we learned about this sample that we're dealing with? So you want to explain your results so that someone else can understand your conclusions, even if they don't understand the background work behind it. So when it comes to statistics, we start by thinking about where we're heading. We want to show what's happening within our data. And then we want to tell everyone, either written or verbally, what's happening in our data set. One really important concept from this class is learning what data is, as well as how to obtain data. So just a vocabulary thing here, datum, it sounds weird, or datum, that is a singular piece of data. I know that doesn't sound right. So when we say data, we're actually referring to numerous, or the plural form of our numerical values. So typically we very seldom will deal with just one number. So that's why data is more of a common term that we use. And later on in chapter 2 and chapter 3, we're going to learn about different types of data. You've probably heard about quantitative versus qualitative. That's basically where we're going. So data can be numbers, they can be record names, they can be labels. And like I said, we'll talk more in particular about that coming up here. But one thing to note is that even if your data is represented by numbers, that does not mean that you have numerical data. So sometimes, I think some of you in this class probably have taken a computer science class. Sometimes you'll code things with numbers. So maybe 1 would stand for female, or 2 would stand for male. Or maybe you have a 0 is yes, 1 is no. Another example I can think of is your student ID numbers. Think about, if we were to take the average of everyone's student ID number in the classroom, would that make any sense? Finding an average ID number? Not really. So typically, if you ask yourself, does taking the mean of these numbers make sense? And it doesn't make sense, it's typically not going to be numerical data, okay? Don't stress too much about that. Like I said, we'll have a whole chapter on numerical and categorical data. But one thing that is important on this slide, data are useless without context. So to me, the beauty of statistics is that it applies to everything we do every single day. So make sure that when you're reporting data or talking about data, that you're going to report what the context of that data is. So as we start studying statistics, we're going to talk about what are called the W's of statistics. Now, on the AP exam, or probably even on my unit test, I probably won't have you just list out what are these, who, what, where, when, why, and so on. But like I said, as we're getting warmed up, it's really important to figure out what these W's are. Moving forward, it will become natural, and I'm going to talk about each of these individually. But in order to provide the full context of the situation we're studying, we need to find the who, the what, when, where, why, and how. Now, like I said, I'm going to explain each of these individually, but the who and the what are what's most important moving forward. And for the how in this list, we actually devote an entire unit to that. So that's how do we design an experiment. Unit 3, we're going to talk all about how to find the how. So let's start by talking about the who. I have stuff here for the band The Who, wonderful band. If you've not listened to them, you can YouTube them later. But in statistics, the who of our data tells us the individual cases for which or whom we've collected the data. So individuals who answer a survey are called respondents. They are a part of our who. So if we send out a survey, people respond to it. Those are the people, the who that we are interested in. Now, people on whom we experiment are called subjects or participants, and animals, plants, and inanimate objects are called experimental units. We could call them subjects as well, but experimental units, that just kind of defines more the context and the people, things that you're studying. Okay. Now, one thing to be very aware of, the who does not need to be a person or a living thing. Typically, when we talk about who, that's referring to a person. But in the context of statistics, the who is just the thing or the people that we are interested in studying. So let's talk about the what and the why. So before we specifically talk about those, variables by definition are characteristics that we record about each individual. And the variables should have a name that identify what has been measured. So when we're determining the what, think of it as what data or what variable, what information are we recording about our participants. So to understand variables, we have to think about what you want to know. And that kind of comes down to the why, which we'll talk about. So when we talk about our what, we are talking about our variables. And as I mentioned earlier, we have two primary types of variables. You up to this point have probably heard of quantitative versus qualitative. Well, instead of qualitative, in statistics now, we're going to call them categorical variables, okay? So a categorical variable names categories and answers questions about how many cases fall into each category, okay? So for example, we could talk about sex. We could say, how many males do we have? How many females do we have? We could do the same thing with race or ethnicity. Those are really common ones that we use. Within each category, we have what are called counts. And that just simply says how many of each thing we have in our data set, okay? So if we look at this table right here, we can pretty easily see that our categories are ground, second day, and overnight. And what we would say our variable is here is it's a categorical variable, but our variable is shipping method. So within our variable category of shipping method, we have ground, second day, and overnight. And then for each of these, we have counts within each category. So 20,000 ground, about 7,800 second day, and 5,400 overnight. So again, shipping method would be our variable. And then within each category of our variable, we have what are called counts. Now, continuing on our conversation of what, we talked about categorical variables. We also have what are called quantitative variables. And quantitative variable, that is just is a measured variable with units that answers questions about the quantity of what is being measured. So these are I've found in the past, these are the variables we're more comfortable with compared to categorical variables. Things like income, height, or weight. So in this table, what I have is a set of students, and then I have the number of AP exams that each student has signed up for. Now, one way to figure out, is this categorical, is this quantitative, is to think, would it make sense to take the mean or the average of our data set, okay? So if we think about number of AP exams, we might take the average of these people and figure out on average, how many AP exams are they taking? Because that makes sense, this is going to be a quantitative variable. Whereas before, when we talked about the different shipping methods, finding the average of those numbers really didn't make a whole lot of sense. So if you're really stuck on, is this quantitative, is it not quantitative, think about, does it make sense to take the average? Now, one thing to be aware of, we have what are called identifier variables. So I mentioned this earlier, student IDs, for example, or credit card numbers, or maybe your social security number. Yes, those are numbers, but we call those identifier variables because, again, if we take the average of those, if I found the average credit card number of all the teachers at Fargo North, there is no value in finding that average. So again, if you're wondering, is this quantitative? Is it not quantitative? Think, can I take the average of this? So if you ask the question, how far can you squat jump? That would be an example of a quantitative variable because we have different people and we could find what the average person was able to jump in a distance of centimeters. Of course, we could also ask about weight. So if we ask the question, how much did your baby weigh when it was born? We could report in pounds, we could report in grams, kilograms. Again, that would be a quantitative variable because we could find in this data set, what is the average weight? So we just got done talking about the what. Again, we typically think about what are our variables, and that determines what our what is. Two more W's that we have are the where and the when. So these are typically given to us when it comes to reporting our final analysis of the data. But when and where give us some nice information about the context of our data. So for example, we could be talking about houses and home values. Well, if I talk about $1 million house, that's going to mean something very different in Fargo, North Dakota compared to San Diego, California. So making a note of where your data is coming from is really important. Also when. So again, if we talk about $1 million house today, that's going to be a lot different than $1 million house 100 years ago or 50 years ago. So again, when it comes to reporting your final analysis of your data, it might be useful to report your where and your when. Now our final W, the how, I'm not going to spend a lot of time on or go into a lot of detail on, but how the data are collected can make the difference between insight and nonsense. So when it comes to Unit 3, which is all about the how, we're going to talk about what does it take to form a really meaningful experiment or observational study. One example that you maybe have seen online is that different websites will have surveys or polls. That we're going to learn later on is probably one of the most unuseful sources of public opinion. You could really, if you wanted to, you could refresh a page over and over again, take that poll over and over again. You're also missing out on a certain set of the population when gathering that information. But when it comes to the how, that's just our methodology behind that experiment, and we will spend a lot of time on that in Unit 3. So I think it would be useful to do an example or two of finding the W's. This is very similar to what you're going to see in your homework. Now, as a precursor to your homework before you dive into it, make sure that you're reading the problem because some of them only say find the who and the what. Some of them will ask for all 6 of the W's. You don't have to do all of them for every single problem, just do whatever the problem asks for. Okay, so let's look at this example. Mr. Kaluza would like to know if implementing a new lifting program will improve his players' free throw percentages. He looks back at free throw percent averages of his current players last season, then compares them to their averages this year. Identify the W's of this situation. So maybe look back at your notes, pause the video for a moment, and see if you can identify the W's. All right, so hopefully you took some time to pause that. So who, remember, that is the subjects or the things or the people we are taking data from. So those are going to be the current players on the team. When it comes to the what, that is the variable or the information we are recording about our who. So here we want to know what are their free throw percentages. Where, we could say that's in Fargo or at Fargo North, more specifically on the girls basketball team. When, not given to us. This could be from right now. We could assume it's from right now, but I guess explicitly we're not given that information. Why? So what's our purpose? We want to see if the lifting program improves free throw makes. And the how? We're going to look back at records of the players retrospectively, and we'll talk about that. And then we're going to compare that to our current performances. So let's do another example. All right, so another example here, let's identify the W's. A research company wants to analyze the differences in teacher salaries across the USA in an effort to see if some regions' teachers are better off than others. To do this, they randomly select 300 teachers from 5 different regions and record their salary and monthly rent or mortgage payment. We want to identify the W's. So again, pause the video, think about what those W's are, look back in your notes if you need to, and then try to practice, see if you can identify those W's on your own. So I have to be honest, I don't know what this map specifically is. I can't read the key on the bottom, but I see that North Dakota is one of the darker blue colors, so I'm curious about what that means. But we'll maybe talk about that later. I'll find that online later. But let's talk about the W's for now. So the who, we are interested in obtaining data from teachers across the country. So those are the things or the subjects we are taking data from. That is our who. What are we recording? Well, we are recording salary information and home payment. Where? Well, we're interested in teachers from across the US, not just in one state or another. So here we're interested in the entire country. When? This is not stated, but again, if we assume this is something we're doing right now, we can just say present day. Why? Now, I know in other classes, particularly English, they say not to plagiarize, but you're going to learn later on that in statistics, we love to plagiarize. We see in the problem, we can take the why word for word from the paragraph. So our why is to see if some regions' teachers are better off than others. That explicitly is our purpose. And then finally, how are we doing this? We are randomly sampling 300 teachers from 5 regions in the US. This is actually a stratified sample, but again, we'll talk about that later on. And final example here. So again, we just want to find the W's of this situation. So Fargo North's head custodian wants to know what proportion or what percent, proportion and percent are interchangeable moving forward, of office chairs in the building squeak when used. He gathers a simple random sample of chairs and records whether or not they squeak. I want you to pause, see if you can identify the W's. All right, hopefully you paused there. So let's identify the W's in this situation. The who, now this sounds really weird because again, typically when we say who, like who were you with last night, you wouldn't say I was with the office chairs, although that's typically who I'm with. I'm sitting on an office chair until I go to bed at night, getting some work done, of course. But here, the who, that's what we're taking our data from. So our who, we're studying the office chairs, that's our who. What are we recording about those office chairs? Well, we are recording, do they squeak or do they not squeak? So that's our variable. Where are we doing this? Well, this is at Fargo North. It says right here, Fargo North's head custodian. So we're in the building. When, again, we're not really explicitly told this, but we could more or less assume that it's present day. Why are we doing this? Well, not stated. Again, we can make assumptions, but we don't want to do that. Maybe he's looking, does he need to oil them? Are they worth replacing? We don't know. And finally, how is he doing this? Well, we're actually given here that he's doing a simple random sample. So hopefully this is making sense finding the W's. I think that once you do a few practice problems, you'll find that it's not too difficult. The homework assignment is relatively short. Moving forward, we're going to get more in depth into specific topics, but I think this chapter does a really good job of giving a general overview. So at this point, hopefully you took some notes. Go ahead and work on that chapter 1 homework assignment. That will be due the next time you're in class.